So we are going to complete and balance the following reactions, determining in each case if a precipitate is formed. We're going to write the molecular equation, the complete ionic equation, and the net ionic equation. So you have been used to writing throughout your chemistry career the molecular equation. So let's go ahead and write the molecular equation. Potassium chloride, KCl, is combined, and this is aqueous because we're in solutions, is combined with lead 2 nitrate. It doesn't tell you what you make, so let's go. We got to think, what are the two things we're going to make? We're going to make lead chloride, and we're going to make potassium nitrate. Now, going to our rules. Are they both aqueous? Is one solid? What do we have here? Lead 2 chloride. Go to your HAL rule. HAL. Insoluble, so it's going to be a solid. KNO3. NO3 is Big Daddy, so it's going to be aqueous. And then we have to go in and we have to balance it. So we put a 2 in front of KCl, a 2 in front of KNO3, and we should be balanced. That is a molecular equation. Now we are going to do an ionic. Well, in an ionic equation, all we're doing is we're breaking these apart. And we'll break, unless they're solid, then it stays together. So we have 2K plus, and it's aqueous, plus 2Cl minus, and it's aqueous, plus Pb 2 plus, and 2 NO3 negative, and it's aqueous. Next, PbCl2. It stays together because it's a solid. And then we get 2K plus aqueous plus 2 NO3 aqueous. Anybody have any questions on that? Yes, sorry. It is still NO3 minus. NO3 minus. All right, net ionic. What is actually going on in the equation? So what I do is I go back to my ionic equation, and what appears on the reactant side and appears on the product side go away. So 2K plus goes away on both sides. And 2 NO3 minuses on both sides go away. So what we're left over with is 2Cl minus aqueous plus Pb 2 plus, bless you, gives me PbCl2 solid. So those things we crossed out are called spectator ions. They didn't do anything in the equation. They just sat there and watched. So usually I'll ask you to do molecular and then net ionic. So I always do my ionic, go through there and cross them out, and then what is still around we do is the net ionic. So let's do another one. Silver nitrate. Silver nitrate is AgNO3, and it's aqueous, plus magnesium bromide, MgBr2, and it's aqueous. In this double replacement, the two things we're going to get is magnesium nitrate and silver bromide. Now we need to decide who's aqueous and who's solid or who's a liquid or whatever. So nitrate is Big Daddy, so that's going to be aqueous. Bromine is a Hal, and Hal is hugging an Aggie, so that is going to be a solid. So this is our molecular. We have our ionic. And our ionic is going to be Ag plus. Oh, hold on. We got to go back and we have to balance that. So I need a 2 in front of AgNO3. And a 2 in front of AgBr. So that means we have 2 Ag plus 2 NO3 minuses plus an Mg2 plus, and these are all aqueous, plus a Br2. Sorry, not Br2. 2 Br minuses. And then we are left with Mg plus 2 NO3 minuses plus 2 AgBr solids. And then we go, and who gets crossed out? The magnesium and the nitrates. And then now we can write our net ionic, which is going to be 2 Ag plus 2 Br minus, and that's going to give us 2 AgBr solid.
So does that technically mean that the magnesium nitrate just never combines, really?
So what I want to do now is let's do one more. Oops, I went one too far, didn't I? Oh, there we go. Okay, wait, am I missing something in here? In my...
Yeah, C, D, and E.
Where'd they go? Hold on. Ooh, they're missing in my PowerPoint. Hold on, let me go. Okay, so here's the next one. silver. We already did silver nitrate, so I put that in there twice, sorry, on my PowerPoint. All right, sodium chloride and lithium sulfate are mixed. So we have molecular is sodium chloride aqueous plus lithium sulfate. Lithium's a -1 and sulfate's or +1 and sulfate's a -2, so Li2SO4, and it's aqueous. And we end up getting lithium chloride plus sodium sulfate. All right, so we need to know the states of matter. Lithium is a big daddy, so it's aqueous. And sodium is a big daddy, so it's aqueous. So you know what happens in this? Nothing. No reaction. So we have a bunch of Na pluses, Cl minuses, Li2, or Li pluses and SO4, 2 minuses, floating around. We mix them together, we mix those two together, and they're still just floating around. So there is no ionic, and there is no net ionic. If no solid form, then nothing. You're not going to have any reaction. Okay, any questions on that? So, no reaction. Okay, now we're going to do some acid-base neutralizations. So sodium hydroxide is mixed with phosphoric acid. So sodium hydroxide NaOH, and it's aqueous. And this is a strong base. Phosphoric acid, what is that? Strong or weak? Oh, let's write the equation. Phosphoric. H is a +1, phosphate is a -3, so it's H3PO4. So, do we have 2 or more O's than H's? No, so it is a weak acid. When an acid and a base comes together, what are the two things we get? A salt. So this time it's going to be sodium phosphate and a water. Thank you. What is the state of matter of water? It's a liquid, so it's an L. So now what we need to do is we need to balance it. When you're doing something like this, it might be easier when you're balancing to leave this as HOH. So those hydroxides are easier to balance. We put a 3 in front of Na. That gives me now 3 OHs, so I need to put a 3 right there. Aqueous is something that's dissolved in water. Okay, so there's going to be several steps here. So if you have a weak acid or a weak base, you're going to leave it together in your second step. If you have a strong acid or a strong base, your next step, you're going to break it apart. So number NaOH, is it strong or weak? Strong. So that means we're going to break it apart. So 3 Na plus 3 OH minuses plus H3O4 we said was weak, so it's going to stay together in our second step.
Would you have gotten points taken off if you didn't write the aqueous for that?
If I asked for you to put it there, then yeah.
Okay.
So the one we're writing is that ionic?
What?
So is the one we're writing right now, is that the ionic?
That's the ionic, yes. Now, sodium phosphate is aqueous, so it's got to be broken apart. So so 3 Na plus PO4 3 minus plus 3 HOHs, water. Now what we do next, that's our ionic, so we do net ionic. So what's on the left, or product, and what's on the reactants go away. So what goes away? Sodium. And now we rewrite our net ionic. 3OH minus aqueous plus H3PO4 aqueous produces PO4 3 minus aqueous plus 3H2O liquid. All right, so strong bases, you write everything how you need to do it, and then in your next step, if it's strong acid or base, you break it apart, and if it's a weak acid or base, you leave it together. Weak base is going to be, well, your strong bases are group 1 and the bottom of group 2. Are your strong bases. So what happens is in here is we really don't get a whole neutralization in this. We don't, we still have a Bronsted-Lowry base in here. So we have a weak base going on in here. Okay? So let's only redo this. We're going to take out acetic acid and we're going to change that to hydrochloric acid. And we're going to look at this at the hydrochloric, or the strong acid, strong base level. So cross out acetic acid and put hydrochloric. So anytime we have a strong acid, strong base reaction, this is what's going to happen. So the first thing you're going to do is write your molecular. So HCl plus potassium hydroxide. So HCl is a strong acid, potassium hydroxide is a strong base. And we're going to get water, which is liquid. And our acid and base are aqueous. And KCl, which is aqueous. Everybody good with that equation? Should be balanced. All right, so these are strong, strong. So we are going to break it apart. H plus Cl minus plus K plus OH minus. And we get H2O liquid plus K plus and Cl minus. So take a look at that and tell me, what are our spectators? Who gets taken out of the problem? Who is just watching what's going on. Chlorine and potassium. And the only thing that we actually make is our water. H plus OH minus gives us water. That's how you know it's neutralized, yes. Okay, so if we were to do this, so that's neutralized. It doesn't have any more acids or any more bases left in it, whereas the one with the weak acid, we still have something in there. It's not a complete salt. Did y'all do anything yesterday in here, or did you just talk? We did stuff.
We did,
Actually,
You? Just ate up this class.
I don't know. I was sick yesterday. So.